Hello, this presentation is about applications of maximum flow or network flow and how to use network flow to solve a handful of common problems. So let's get a shared definition of what network flow is. We consider the maximum flow of a given directed graph between two special nodes called the source and the sink, sometimes referred to as S and T, as the maximum number of edge disjoint paths between nodes S and T on our given graph. Specifically, this is the maximum number of paths that you could take from S and T while only using each edge at most one time. So on this example graph, we can see that there are two potential paths between S and T, and we cannot get a third path between them without reusing an edge. If we were to add a edge right there between the bottom left white node and T, we can now see that there is a third potential edge disjoint path between S and T, and so the maximum flow of this graph would be 3, while the maximum flow of the previous graph before the edge addition would be 2. You sometimes will see for your input graphs edges with capacities. If we see any unlabeled edges, we can assume a capacity of 1, but sometimes there are labeled capacities. And so if an edge has a capacity, it is equivalent to multiple copies of edges between the given nodes that it connects. So we see on this graph with an edge with capacity 2, that is equivalent to having 2 edges between the top right node and the sink, and then using our same definition as before as the maximum number of edge disjoint paths. And so we see the maximum flow of this graph with that one edge having a capacity of 2 would be 3. And the middle white edge would not be used. So sometimes we also see capacities on the nodes. This is not quite as frequent, but can be simulated by essentially splitting the node with a capacity, or splitting all nodes and assuming nodes without a capacity constraint have a constraint of infinity, and creating an edge between the input node, which takes in all incoming edges, and the output node that outputs all outputting edges from this node. And then if we connect those with an edge, then we can still use our maximum flow algorithm, and we can use the capacity of this edge to simulate the node having a capacity. And so this is a new graph, a new split node graph. And so these are the different kind of information that you might have when computing the maximum flow. So how do you compute the maximum flow? There are many different specific algorithms for computing the maximum flow. Maximum flow is not one algorithm. It is a kind of problem that can be used to solve other problems. And so the simplest algorithm, which unluckily has the worst runtime, would be the Ford-Fulkerson algorithm. And the most common one to be used is Dinix or Dinitz with capacity scaling. I will not go over these algorithms. There are many sources that you can use to develop an implementation or use someone else's development of an implementation of these algorithms. And for now, we can treat the ability to compute the maximum flow as a black box that we assume we can do.